Okay, I think we're finally recording. So the project that I decided to pick was arginine. It is, I'll go here first. It's a deficiency of arginase in humans. It's an inherited disorder and it causes a buildup of the amino acid arginine and ammonia in the bloodstream. So how this works is basically, I'm not going to go too far into it because it's kind of confusing, but arginine is supposed to excrete urea, and then once that's excreted, it turns into orthanine, and once ammonia is added to that, citrulline comes into the picture, and then it's converted to argiosuccinate, and then it's just a cycle. But without arginase, arginine can't get excreted, urea builds up in the blood. So how it happens: ammonia is formed when proteins are broken down in the body. If not enough ammonia is excreted, it becomes toxic in the blood because levels get too high. Symptoms usually present by age 3. They include leg spasticity, growth patterns that are slow, and developmental delays. Most affected infants are actually identified at birth now through newborn screening, which we just learned about. So this works because arginase activity is detected in red blood cell counts, and molecular testing is used to confirm or deny the diagnosis. The molecular cause of it is mutations in the ARG1 gene, and it's located on chromosome band 6q23. This mutation leads to nonsense-mediated protein decay, and it causes devastating neurological and cognitive dysfunction in humans. And we learned that nonsense is a premature stop codon in the body. We learned about that all semester. So the mode of inheritance is autosomal recessive. I just inserted a little recessive Punnett square here, but if there was a big T and a little t and a big T and a little t, there'd be a chance for your children to have argininemia or not. Yeah, if there was an uppercase T, the gene would be suppressed because its mode of inheritance is autosomal recessive. So here you just have a little pedigree, and as you can see, it's passed down recessively through males and females of the family. Both parents don't have to have the disease to give it to their offspring, and yeah. So genetic testing options include, again, the newborn screening programs, and then if a newborn baby's arginase is out of range, then blood and urine samples are taken to get a confirmatory result. High amounts of arginine in the blood and orotic acid in the urine are indications that the baby probably has the disorder, and that's when you would need blood and urine samples. And then what happens next? Further testing is required to establish a confirmation or ruling out of the disorder, just like I said. And then the testing should take place as soon as possible because early detection could lead to a potential normal life, whereas the child could severe side effects mentally, cognitively, physically, otherwise. So treatment includes early detection, protein and arginine limited diet, dialysis, supportive therapy, and then IV sodium phenylacetate and sodium benzoate. And here are my references. And yeah, that's argininemia. Thank you. How do we stop this?